We all think of artificial intelligence as something, well, kind of magical, right? Something that just exists out there in the cloud. But behind all that magic, there's a very real, very physical world of concrete, power, and water that makes it all possible. So today, let's pull back the curtain and uncover its hidden cost.
I mean, think about it. You type a question into a chat box, and a perfectly written answer just appears. You describe some crazy image in your head, and poof, it materializes on your screen. The whole experience feels completely seamless, like it's happening somewhere else, somewhere in the cloud. Yeah, these are the words we use, right? Weightless, instant, digital. There's no heavy machinery humming in your office, no smokestacks you can see from your window. It just feels like pure information, existing only as ones and zeros.
And that's the big question, the one we're really digging into today. Because here's the thing, AI isn't weightless at all. It has a massive physical footprint, one that's built on a very real foundation of power, water, and raw materials.
This brings us to a really fascinating paradox. On one hand, AI is being talked about as this incredible tool that could help us solve huge problems like climate change. But on the other hand, the technology itself has this enormous and rapidly growing appetite for the planet's resources. The United Nations University put it perfectly with this question: is AI a climate hero or a hidden villain? The answer isn't a simple yes or no. It's not a story of good versus bad, but a really complex trade-off that we absolutely need to understand. All right, so let's start breaking down these physical costs, and we'll begin with the most obvious one, the incredible, almost unbelievable amount of power this AI boom requires.
Just look at this number, $2.8 trillion. According to Citigroup, that's the forecasted spending on AI data centers by 2030. A number that big isn't just an investment, it signals a fundamental shift in our entire global infrastructure.
And here's why that investment is so massive. An AI data center isn't just a slightly bigger version of a normal one. It's on a whole other level. A standard server rack in a traditional data center might use, say, 5 to 10 kilowatts of power. An AI rack? It starts at 60 kilowatts, and it only goes up from there.
So to try and wrap your head around this global hunger for power, get this. The International Energy Agency projects that soon the electricity demand from data centers, mostly driven by AI, could be equal to the entire current consumption of Japan, an entire industrialized nation. Wow.
Okay, so where is all this power coming from? Well, in the US, a whopping 40% comes from natural gas, and another 15% from coal. So yeah, that means over half of this immense energy demand is being met by burning fossil fuels. It's a direct, undeniable line connecting the digital world of AI to real-world carbon emissions.
But the cost isn't just measured in watts and carbon. Not even close. Let's widen the lens a bit and look at AI's thirst for other critical resources, starting with something you might not expect: water. 5 million gallons. That's how much water a single large data center can slurp up in a single day. All that water is absolutely essential for one thing: cooling the thousands upon thousands of processors running at full tilt, 24/7.
I mean, 5 million gallons is a hard number to picture, so let's make it real. That's the same amount of water used every single day by a small city of up to 50,000 people. And this is putting an incredible strain on local water supplies, often in places that are already dealing with drought. And here's where it really hits home for you and me. Every time you interact with one of these large language models, you're part of this consumption. Researchers estimate that just a handful of your queries, maybe 10 to 50 of them, can use up an entire bottle of water just to cool the servers processing your request. But believe it or not, the environmental impact starts long before a single watt of power is used. Let's zoom way in, down to the hardware itself. This right here is an NVIDIA HGX H100. It's basically one of the engines of the AI boom, and its environmental cost begins the moment its components are created. So there's this thing called a cradle-to-gate analysis. It basically looks at the carbon footprint of a product before it even leaves the factory. And for this GPU, it's just staggering. A full 91% of its total carbon footprint is generated before it's ever even used, just from mining the raw materials and manufacturing all the tiny components. And if we break that down even further, you can see the biggest culprits. The production of the high bandwidth memory alone accounts for 42% of that pre-use footprint. Then you add in the integrated circuits and the thermal components needed to keep it cool, and boom, you've accounted for almost all of the emissions. Now here's the crazy part. The cycle of use is brutally fast. These specialized, incredibly expensive chips can become obsolete in as little as 1 to 8 years. This rapid turnover is creating a mountain of electronic waste, and it's projected to add up to 5 million tons by 2030 alone.
Okay, so I know we've laid out some pretty significant costs, but remember that paradox we talked about at the beginning? Let's flip to the other side of this double-edged sword. Because AI is also being used as an incredibly powerful tool for climate action.
And you can see that conflict so clearly right here. On one hand, the very same technology can be used to optimize and more efficiently extract fossil fuels. It can even create climate disinformation. But on the other hand, it can help us forecast extreme weather, discover new sustainable materials, and make clean energy grids way more efficient.
So with this huge paradox in play, it's no surprise that people are starting to notice. Societies are really beginning to grapple with this explosive growth, from local town hall meetings all the way up to national governments.
And it's not just academics and governments. All over, regular communities are starting to push back against this unchecked expansion of data centers. Why? Well, they're seeing their own energy bills go up, their local power grids are being strained to the breaking point, and their water supplies are stressed, all while they have to deal with the noise and pollution from these giant industrial facilities.
And it looks like governments are finally starting to respond. In the US, we're seeing proposals to actually study and standardize how companies report on AI's environmental impact. In the EU, big data centers are now required to report how much energy and water they're using. It seems like the era of them operating completely in the dark is slowly coming to an end. So, what does this all mean? It means the future of AI isn't some predetermined path written in code. The conversation is really shifting from just what the technology can do to what we as a society choose for it to do. Are we going to prioritize this unchecked, explosive growth at any cost, or will we demand a smarter, more sustainable path forward? The choice really is ours to make.